Good morning, everyone. In our previous classes, we learned how memory can be allocated dynamically using malloc and released using free. We also discussed why dynamic memory allocation is essential when the size of a data is unknown during the compilations. Today, we are going to apply that concept to solve practical problem matrix multiplication using dynamic memory allocations. So instead of declaring the fixed array size such as int a of 10, 10, we will create matrix dynamically according to the size entered by the user. So this concept is widely used in image processing, artificial intelligence, and machine learning, scientific computing, robotics, and computer graphics. Let us first understand what exactly the matrix is. The matrix is simply the collection of data arranged in rows and columns. For example, it is 2, 2 matrix, right? So it is 2 row and 2 columns. So this matrix is having 2 rows and 2 columns. So in C programming, we generally represent the matrix using two-dimensional array. Here, this A is equals to A is a matrix and that is represented by means of A of I comma j, and M and M, it is a M cross N, it is row and column matrix, and B is N and P is a row and column matrix of this B. Then the products which generally represented by means of A into B, which represented by means of C matrix, C, I and J. So the definitions of this matrix multiplication indicates you have to multiplying that values by means of rows and columns, row by column multiplications. So that should be represented by means of this following representations. So BAB is obtained by multiplying the entries in the ith row of A and the corresponding entries in the jth column of B. So and then you are supposed to adding the results. Means that the row of this first column, first matrix, and the columns of this one, and that is multiplied with that is added by the first row and second column, first row plus first row and third columns, and so on till that. So that is equals to this resultant matrix C. Generally this algorithm, that is, you have to start the program, enter the row and column of the first matrix, that is A matrix, and this is enter the row and column of the second matrix, that is called as a B matrix. Enter the elements of this matrix. So after getting this row and column values, row and column, you have to enter the values of that one by filling the matrix of A over here. And the next step is you have to enter the elements of the second matrix B and print the elements of the first matrix in the matrix form, and print the elements of the second matrix in the matrix form, and set up the loop which could be used for doing the multiplications between that. So how to do this inner and outer loop for this column, and this multiply the first A and second B matrix and store the element in the third matrix of C, and finally the result is stored in the C and that will be print over here, and finally this stop the program. So this is an algorithm for this normal matrix multiplications. So this is a program which could be representing your matrix multiplications. So you have to read the matrix sizes, validate the dimensions, allocate the memory for A and B. That should be done if you are using this malloc operations, and you have to performing it. So here in this matrix multiplications, this is a preprocessed directives for the C program, and then in this main you have to declaring the size of the A matrix, B matrix, and this multiplication matrix, that is called as a C matrix. and this R, C are the row and column. So you have to first getting this row and column values, and then this for loop which could be used for getting the values of A matrix, and this two for loop which could be used for, this is used for getting this B matrix values, and this could be used for multiplying this matrix. So where in this multiplication of this matrix, initially that should be represented as 0, and you are using one more for loop for doing this multiplication, that is called as a K matrix. So this K matrix is equals to 0 and it is varies till this C value, that is column values of this matrix, and this formula could be used for doing this multiplications and printing the result of this one. So this is how it should be happens on this. So the output, when you are running this program, you will be getting the output as enter the rows and columns, first matrix, second matrix, and after doing this multiplication it will display you the final matrix. So the similar program which could be modified by means of this dynamic memory allocations now. So this dynamic memory allocations, what we are supposed to do was this algorithm read the matrices and validate the dimensions and allocate the memory for A, B and C, and read the inputs, initializes C is equals to 0, and perform a triple nested loop for multiplication, doing the multiplication, and finally it will return the result. And since you are using this malloc operations, we have to free the memory space by using this free functions. So this DMA could be implemented over here. So it allocate two pointers using malloc, and then allocate each row separately. So you are using this two pointer, that is pointer to pointer, right? So this program explains you the memory allocation, input loops and multiplication loops and output printing and memory deallocations, right? So here what it happens, that's why you are using this two pointers for this three matrix. This is first matrix and this is second matrix and this is a resultant matrix. So it is a two dimensions. So for allocating the memory you are using this two pointers, and these are all the row and column for this first matrix, and this is a row and column of the second matrices. In addition to that, you have to use some variables, initializing these variables I, J and K, right? You have to get the scan the values of this rows and columns, and next one is you have to check whether this first column is equals to the second row. So if it is not, we can't do the multiplications. So that is a generalized rule. So this could be used for doing this multiplication as a meaningful way or not. And for this allocating memory allocation, this is very important in this matrix dynamic memory allocation using matrix multiplications. So with the help of these statements, you have to allocate the memory for the matrix 1. So means that it is A. So here this A is a double pointer. We did that specified in a declaration part. This is double pointer of A. So have to taken this A over here, and it is a size, it is you are representing that as int of multiply with this row values, first matrix row values, and this is called as typecasting. So here you are using this pointer and pointer to the pointer, and here in the size of you are using this single pointer, and for this row you are supposed to use this allocating the size for this one. Similar to that, you have to use this allocate the memory for the second matrix. So this could be used for this one. Similar to that, you have to allocating this matrix for the C. So here in the first one you have to use this double pointer, and then you are using this for loop. Within this for loop you are allocating for each and every pointer memory allocations for each and every rows, and finally you are doing this matrix multiplications, similar set of statements what we have doing over here for the previous one, and finally we are supposed to get the print the result of this one. So this is a very simple program where we are supposed to use only the pointers, mean that matrices A, B and C all are represented by means of this double pointers, and we have to allocate the memory for each and every individual matrices what we are using in this program. So here in this a matrix multiplication program, this time complexity is n cube. So this is a time complexity for this matrix multiplications. So this DMA provides a flexibility and efficient memory usage for this matrix operations. Thank you.